Inversal is a product development ecosystem bringing together the future of conceptualization to mass production of various products that include embedded firmware of electromechanical devices. In the process of providing product development consulting, we actually develop our own products as well in areas such as advanced manufacturing, additive manufacturing, cloud computing, and artificial intelligence. The name Inversal comes from instant and universal, which is really our guiding light with what we do with our customers. We're trying to provide an instantaneous service and solution with a universal approach. This is directly applicable to one of our products that we're going to go into more detail today, CoolTool, which is really intended to provide a solution to all mold makers and molding shops across the globe. Conformal cooling has been around for over a decade. It's not a new technology, but it still hasn't lived up to the hype, unfortunately. It's been around for a while and is not being adopted. When we set out to produce CoolTool, it was built around the hypothesis of a few things, specifically with a problem in mind. People don't know which parts are a good fit for conformal cooling. Even if they know what is a good fit, they are not really well suited with the tools to design conformal cooling channels that could perform from a thermal perspective as well as a production perspective with regard to additive manufacturing. And then even validating the performance improvement is really a black box. So with regard to CoolTool, we actually are able to address all three of those issues. So with regard to the three areas we just discussed, the first is predictive engineering modeling and how it could be leveraged to define how to pull the heat out of the process to cool the part as quickly as possible. One of our lead engineers, we're fortunate to have him on our team, has over 40 US and international patents, and we're actually leveraging technology that was used for the semiconductor manufacturing equipment space into conformal cooling with additive manufacturing. So we're able to identify with a generative design process how you can lower the cooling time as much as possible with the use of additive manufacturing. So before you even decide that you want to move forward, we could guarantee the improvement from an ROI perspective on cycle time. The second area is like you could do predictive engineering modeling and have a design in theory that cools a part well, but is it actually manufacturable? And I actually have here a demonstration part of what we're doing on the software design side to enable printable cooling channels. So auto routing as it relates to cooling has been around for a while. We actually take mathematical models as it relates to printability. So if you think of the inclination angle as it relates to the normal plane of a print, we could change the profile of the cooling channels to make sure it's printable. So not only is it improving the thermal performance, but that design is going to be directly transferable into a printable part and seamlessly go from concept to production. So the third part with regard to our hypothesis on the adaptation of conformal cooling is validating that the improvement you said you were going to get, you actually get. One of our core values of the company is transparency, and we're working to provide a transparent cost model from the OEM to the part producer to the mold maker. And we do that through machine monitoring, so actually validating the cycle times on parts, and even looking at process parameters and using artificial intelligence to define if that process is going out of sync before it happens to make sure you get the process back under control. We're really excited with regard to this print because alongside International Mold Steel and their HTC 45 material, which is essentially a traditional H13 but leveraged for 3D printing, it actually has better thermal conductivity. So if you're trying to reduce your cooling times, it's like the perfect fit. It also performs well with printability. There's no cracking, and we're looking at 1 million cycles actually with this material. So if you're working with injection molded parts where cycle time is really important, or you're dealing with critical dimensions and tolerances, it's a really good fit, CoolTool, because we're able to control both the time-cost relationship and the dimension tolerance relationship as it relates to pulling heat out of the part. In the past, it's been really challenging to tie all the steps together to both optimize and produce a 3D metal printed conformally cooled insert. And we're here to help at any stage of the process to make it easy and seamless for your process, whether you're a mold maker, a part manufacturer, or you're purchasing injection molded parts.